This is video number 1 for sections 3.5 and 11.1, describing inequalities. So we're approaching the end of our unit on linear functions, and essentially what we have in these last couple of lessons is an answer to this question. What happens if we redo some of what we've been doing, but instead of using an equal sign, we use one of these symbols. These are called inequality symbols. Less than, greater than, less than or equal to, greater than or equal to. What if we start using these symbols instead of an equal sign? And so that's what we're going to talk about in this lesson and in the next one. This video starts with just the idea that these inequalities can be described in a variety of ways. And so let me show you what I mean by that. Here is a starting example. Kind of a funny looking graph. It has a starting dot here. It goes up a little bit and then it goes down forever. And the arrow means, of course, that it goes down forever. If I were to ask you what the domain is of this function, that's an idea we've practiced before. Remember, domain is just a list of all of the x values that ever show up on this graph. Well, there are a lot of x values that never show up on the graph, like -1 and -2, even 0 is not on the graph. The graph doesn't start until this spot right here, which would be an x value of 1. Now, after that, every possible x value after is eventually used, especially because this thing goes on forever, right, in a rightward and downward direction. So I might say something like the domain is all numbers 1 and higher. And that's fine, but how can we describe that set of numbers mathematically? Well, it turns out there are 3 ways you can describe this set of numbers. The first way is using an inequality symbol. That's one of these 4 symbols that we talked about up here. And let's see. In this case, I'm talking about domain, so I'll use the letter x. And I would be saying, well, x can be anything that is bigger than 1. And actually, it can also be equal to 1, so I would have to put that on as well. So all x's that are greater than or equal to 1. That's the inequality symbol way of writing the domain. A second way that you could write it would be to draw a picture. Now, I'm not talking about an XY picture. I'm talking about a number line graph. So just a simple number line extending in both directions, because remember, I'm just here trying to draw a picture of the x's that ever go on this graph. Well, let's see, we said 1 and above, so you would mark some scale like I've just done on your number line, and then right on the line, not above or below it, but right on the line, color in all the numbers that we're trying to describe. So we're starting at 1, and then we're saying everything higher than 1. The filled in circle here at the start tells me, okay, I'm starting at 1. The arrow at the end means, well, this goes on forever, 1 and above. So that's a number line way of describing this set of numbers. The third way is called interval notation. This one might be new to you. I find that it's easiest to get interval notation from the number line picture. Here's how it goes. Take a look at what you drew on the number line picture. I'm talking about the red graph. Write down first the number that's farthest to the left. Well, that would be 1. The number farthest to the left on my red picture is a 1. Then put a comma, and then put the number that you colored in farthest to the right. Now, that's kind of a strange question because this arrow means it goes on forever. Well, we have a name for that in math. It's called infinity. Infinity is like a sideways 8. That's the symbol for infinity. This means, oh, all numbers from 1 to infinity. Then around the numbers, you either put a set of parentheses or a bracket. Most of the time you use parentheses. You only use a bracket if you have a filled in circle. So infinity does not have a filled in circle. Infinity always gets a parentheses, but that 1 has a filled in circle, and so I put a bracket around it. The bracket communicates including 1. Okay, that's the meaning of the bracket, that 1 is included in your set of numbers. If I put a parentheses there, it would mean no, not 1, only the things more than 1. This is called interval notation. It means the same thing as all these other things. It just means all the numbers starting at 1 going all the way toward infinity. 3 ways of describing the same set of numbers. Let's try a second example. I didn't make a graph or anything this time, but let's say that we were looking at some function and we figured out that the domain was all numbers between -3 and 5. And when I say not including the ends, I just mean not -3 and not 5. So let's try to describe that set of numbers in those same 3 ways. First, with the inequality symbols. Between, you may remember, has its own special notation. And the way between goes is you take your variable, I'll assume I'm still dealing with x here, and you put it between 2 less than symbols. It's always an x or whatever variable between 2 less than symbols. Then the smaller number goes on the left, that would be the -3, and the bigger number goes on the right. Let's see, do I need the little equal signs? I think I don't, because I'm not including those ends. So here would be the final statement, and you can even read this. I mean, some people try to read it -3 is less than x is less than 5. That's true, but it's not very helpful. The helpful way to read it is x is between -3 and 5. So that's how you would write it with inequality symbols. What about a number line graph? Well, I'm going to have to come over and make some scale on here. I definitely need to go all the way to -3, and I need to go to at least 5 over here. So I've drawn a number line, I've filled in sufficient scale. Let's see, and I'm trying to color in all the numbers between -3 and 5. I don't think I'm going to have an arrow on this one. I'm just going to be coloring in between those numbers and then stopping. Now here's the thing. We're not including the ends this time. So on the picture, instead of doing a filled in circle, you do an open circle. An open circle deals with the fact that I'm not including the -3. I'm still going to color in everything in between. You know, all this stuff is part of the answer. Remember, it's right on the line. It's not above it. You're shading the actual line. And of course, I'm going to go all the way down to the 5. And what am I going to put at the 5? Well, I'm not including the 5 either, so I would need an open circle there at the 5 as well. And there is my final graph. Again, the open circle is because I'm not including the 5. So here's a picture of all numbers between -3 and 5. Lastly, let's see if we can figure out the interval notation for this set of numbers. Remember, the easiest way to get the interval notation is to look at the number line picture. I take the number that is part of that red graph farthest to the left, that would be the -3, then a comma, the number that's farthest to the right, that would be the 5, and then surrounding them I either put a parentheses or a bracket. Remember, the only time you use a bracket is if you want that end to be included. I don't want those ends to be included, and sorry, this should say -3. I don't want those ends to be included, so I would put a parentheses here and I would put a parentheses here. This would be the interval notation. I will tell you one very unfortunate thing about this notation is this kind of looks like an ordered pair, right? It is not an ordered pair. It has nothing to do with an ordered pair. In the world of inequalities, this means all numbers between -3 and 5, not including the n's. We'll continue to practice with these three ways of writing inequalities as we go through the lesson.